So let's just see how we can represent a polynomial using the linked list. So suppose we have the polynomial 2x square plus 3x plus 4. So in this polynomial, this is the coefficient and this is the exponent. Now we can represent this term using one single node of the linked list. So this is a single node. Now inside the node we can store the exponent and the coefficient. So here we can store the exponent and the coefficient, and then it will have the link to the next node. So like an example, here we can store the coefficient 2 and the exponent 2. So this is the first node, so the head pointer will point to this node, and then it will be linked to the next node, and the next node will contain the coefficient of this term. So here the coefficient is 3 and the exponent is 1. So this term is represented here. Similarly, we can represent this term also. So we have to create another node and we can connect with a link. And here you can see we only have the coefficient. So here we can store the coefficient 4 and the exponent is 0. And because this is the last term, so it will point to null. And you can see we have represented this whole polynomial using this linked list. So let's just see how we can define a single node. So here we're going to define one single node. So we're going to use the structure. So struct node. Now inside the node we're going to have the coefficient and the exponent, and also we're going to have the link to the next node. So that is the structure of a single node. And let's now see how we can create one single node of the polynomial. So here we can create one node. So let's just define the function create node. So the function will take the coefficient and the exponent of the polynomial. So here we're going to create one new node and we have to allocate the memory. So we're going to use the malloc. So we are allocating memory for a single node. So we're going to typecast it to the node type pointer. So our new node is ready. Now we have to store the coefficient and the exponent in that new node. So here we're going to store the new node's coefficient, and also we're going to store the new node's exponent, and the new node's next pointer will be null. So our single node is ready with the coefficient, exponent, and the next pointer will point to null. Now to create a whole polynomial, we need to connect these single nodes together using the link. So for that we can use a function. So we're going to write a function to insert node of the polynomial. So the function will return struct node pointer. We're going to call the function insert term. Now first of all the function will take the head of the polynomial, then we're going to pass the coefficient and then the exponent. So inside the function, first of all let's just create a new node and we're going to call the create node function, and here inside we're going to pass the coefficient and the exponent. Now all you have to do is you have to check if the head is pointing to null. So here we are checking if the polynomial is empty. So in that case we're just gonna return the new node as the head node. Otherwise, if we have nodes in the polynomial, now to insert a new node we have to use one temporary pointer which will initially point to the head. So here we're gonna create the temporary pointer which will initially point to the head. Now we have to traverse to the last node. So we're going to use the while loop. So the loop will continue as long as the temporary next pointer is not null. Now in each iteration we're going to shift the temporary pointer to the next node. So that means we are just shifting this temporary pointer until we reach to the last node. And when we reach to that last node, then we can insert this newly created node at the end of the list. So here we can just simply modify the next pointer and it will point to this new node. And after inserting the new node at the end of the list, we can return the head pointer. And this way we can insert a new node at the end of our polynomial. So this way we can insert all the term one after another, and our full polynomial will be represented using the linked list. So like an example, inside the main method we can create the polynomial p1, so which will initially be null. So let's just insert the term. So the first term contains the coefficient 2 and the exponent 2. So first of all we have to pass the head, which is p1, and we have to pass the coefficient and the exponent. This first term will be created. Now we have to create this second term. So we're gonna pass 3 and 1. Similarly we have the third term. So it has the coefficient of 4 and the exponent 0. So here we're gonna pass 4 and 0. So this way we have created this whole polynomial using the linked list. So our polynomial is ready. Now here we can write the function to print the polynomial. So we're gonna call the function print polynomial. So the function will take the polynomial. Now inside the function we're gonna traverse the polynomial to print their nodes. So we're gonna use one while loop for that. So the loop will continue as long as the p1 is not null. Now inside the loop, first of all we're gonna print the coefficient, so p1 dot coefficient. So after that we have to check if the exponent is greater than 0, then only we're gonna print the term x. If the exponent is greater than 1, then only we're gonna print the exponent. So here we're gonna print the p1 dot exponent. So if the exponent is greater than 0, then we're gonna print the x, and if the exponent is greater than 1, then only we're gonna print the exponent. Now in each iteration we're gonna shift the p1 to the next node, and also we have to add this plus symbol between the terms. So here we can do that. If the p1 is not null, then only we're gonna print the plus symbol between the nodes. So now here we can print this polynomial p1. So we have to call the function print polynomial, and we can pass p1. And here you can see we have the polynomial 2x square 3x plus 4. So this way we can represent a polynomial using the linked list. So hope you understand the concept. See you in the next one. Take care.